Hello everyone, this is BronyCalc, and welcome to the final chapter of our Parity quest. Today we tackled the last big question. Is phi, odd, even, Steve, or pseudo-Steve? Believe it or not, the answer will change everything about this series. So, we established in the last video that infinites are weird and hard, and we don't like dealing with them, and they don't even really give consistent answers. So, instead we'll need another way to go about this. Fortunately, unlike pi or e, phi is algebraic. So, if we want to go down that route, we should get something like, let's see here. You're going to have to pardon me, I don't remember the exact equation. That should be right. Yep, that's right. So, using this, we can now, I'll start testing odd and even since those are the easiest. So first off, if this is odd, then this is also odd, and these are even. This is odd. Even minus odd equals odd. Doesn't work. We try out something similar here. Even minus odd is even. No. So, we've already eliminated these first two, so the question is, does this have an order of Steve, or is this a pseudo-Steve? Now, the first time I went about this, I tried like every possible order of Steve. I tried fractionals and all that, and that just got messy and complicated. But there's a much easier form of analysis. To start, I'm going to rewrite it like this. And so we have an odd and something which I'm going to say has order n as a Steve. And since this is squared, when we multiply, we add orders. So this is an order 2n Steve. So, we have an order 2n Steve, and since x is an order n Steve, minus x must be an order n Steve. And we want them to be odd. Well, if we have two Steves, adding up to something that isn't a Steve, they must be at the same order, as we learned back in part 5. So, we need 2n is equal to n, and n is greater than 0. I'm going to give you about 5 seconds. 3, 2, 1, doesn't work. So, since no order satisfies this, we know that phi is a pseudo-Steve. Well, now we have to explore something pretty important. Because if phi is a if something is a pseudo-Steve, what do we say? Let's say n is a pseudo-Steve. What about 2n? Well, let's say, if 2n is a Steve, then it has an order. And then n would have that order plus 1. N would be a Steve instead of a pseudo-Steve, so that's clearly not what we're looking for. Similarly, if it were odd, then we would know the order. Then we would have an order 1 Steve. And if it were even, we should get another even or an odd, or maybe a fractional order Steve. You never know, but we should not be getting a pseudo-Steve. So, if n is a pseudo-Steve, 2n must also be a pseudo-Steve. Well, that's a problem, though, because we know what phi is. We have a much nicer form for phi. 1 plus root 5 over 2. So this, by necessity, is a pseudo-Steve. But if we multiply 2 phi, that's 1 plus root 5. And if you go all the way back to part 2, this is odd, so the sum of these must be even. So an even number is a pseudo-Steve. So, we have two conclusions at this point. We could try developing a whole new set of rules like we've done like 2-3 times now. Or we could look at this and finally come to the conclusion that there's just no resolving this. When it comes to the end of the day, we're going to find more and more and more exceptions. So let's let phi be the straw that breaks the camel's back and just acknowledge that ever since we threw fractions in part 3, I believe it was. Yeah, it was part 3. Ever since then, we've been trying to keep a dead horse alive, and it was already dead, and we just need to let it go. Still, it's been fun though. We developed our own little ways of counting certain things. We got different groups of numbers. We still have our rules for our integers. We know how these work. If we want to, we can say that we know how the nth roots of integers work as well. We can still go up and look at we could still look at like I plus 2 and say that's not a number. Gaussian integers are still subject to parity, it appears. And we could work with other stuff, quaternions, octillions. We just simply can't apply it to every number. And I think in the end of the day, that's an important part of mathematics, is just realizing when there's no answer. So, with that in mind, it's finally time to say goodbye to our parity quest. I hope you really enjoyed this. Don't forget to like, comment, subscribe, and maybe join me for my next video, whatever that'll be. Thank you, and see you later.